Many thanks to PCBWay for sponsoring this video.
Good day everyone, and welcome back to DX Explorer for another video. Today I will do a very short introduction. I was asked some while ago by a kid in one of the emails that I received if I could build a bit frequency oscillator, so basically a BFO based on 455 kHz as base frequency, to be used with a shortwave receiver in order to be able to receive CW and SSB signals. Unfortunately, I do not have a shortwave receiver that has an high frequency of 455 kHz to be able to test it, but we will measure the frequency with a frequency counter to make sure that it resonates on the frequency that we need. And I'll try to see if I can actually receive it on one of the receivers that I already have over here, and basically listen to the sound of the oscillator on 455 kHz. So anyway, I'll try to keep it short. Let's get straight into the subject, but of course not without saying thank you to my friends at PCBWay for always sponsoring and supporting the DX Explorer channel. They have great PCB prototyping services, CNC, 3D printing, SMD stencils, and the most important, they also offer assembly services. So if you order one of the projects that I'm building and designing here on the channel, if you go on the video description of this video as well, you'll be able to order the PCB board that I designed for this bit frequency oscillator, and you can also order the assembled version if you don't feel like playing around with a soldering iron. They also have a great store where you can buy interesting things for your project, and that's one of my favorite places where I always go and stop and I pick up things when I make my orders for PCB boards as well. If you don't have an account for PCBWay, please have a look in the video description and use the provided link over there. You'll get a discount on your first order. As I'm always saying, PCBWay is the way. So on the screen you have the simple schematic of the bit frequency oscillator, which obviously is nothing but a simple oscillator based on a 455 ceramic filter. It works fantastic. I've been testing it and I built it really quick on a breadboard just to make sure that it actually works properly before I'm designing the PCB board, and I wanted to check the values of all the components. I'm not going to put the LED in the final design on the PCB board just because I'm thinking that it will be used from a 9-volt battery, and to minimize the power consumption I will cut the LED from the schematic. So anyway, since I don't have shortwave receiver that has an high frequency of 455 kHz, I'm going to use this simple frequency counter to check the frequency to make sure that it does resonate on the frequency that we want, and also we'll be able to make a few little adjustments to that frequency just in case we might need it. Now remember, this frequency counter, it's a modified, it's not the standard kit frequency counter that the way it usually comes. In the video a long time ago that I posted about this one, have a look in the video description. You'll find a link to another video that I found on YouTube and helped me modify this frequency counter to be able to measure smaller signals just because it needed a preamplifier. And basically what I did, I transformed the oscillator circuit that was used to test crystals. Now it's transformed into a preamplifier. You can leave it as it is and build an external preamplifier to this one, and also keep the crystal tester. I didn't need that one, so yeah, I modified it this way. But just so you know, just because I'm getting a lot of comments on this one asking me about the way I modified it. So anyway, let's get back to the bit frequency oscillator. I'm going to power it really quick, but before, let me connect the the frequency counter really quick over here, and the ground it will go over here. So right now I have this battery that will power the BFO, and I have another battery that will power my frequency counter, and I'm not sure how well you can see it. Let's see, maybe with a little bit of light. I'll try to keep some shade, and the battery connection is not so good. So right now, with the variable capacitor at the minimum, it's 453.55 kHz, and with the capacitor on the other side, it's 457.38 kHz. So this way we can basically tune it on 455 kHz. It's a little bit harder with one hand. Anyway, 455, and if needed, then you can make little adjustments and go a little bit lower in frequency or a little bit higher. And this is the way that I picked the components to be able to make these small adjustments, just in case we might need this. So I'm thinking now, let me turn this off really quick. We're going to test it in a little bit on the receiver to listen to the signal generated by the BFO. Basically, over here you will have on the PCB board, on the output of this capacitor. Right now I'm using, I believe, 47 picofarads just to pick up the signal from the oscillator to be able to measure it with a frequency counter. But over here it will be a 1 nanofarad capacitor, as you could see earlier in the schematic, and from here it will go to one single pin that it will be installed on the PCB board, and that is the pin where you will solder a simple piece of wire, just like this one over here, maybe, I don't know, 20 centimeters long, that you will use as an antenna that will go closer to your receiver in order for the receiver to pick up the signal from the bit frequency oscillator, mix it, and you'll end up being able to listen to CW and SSB signals. Sorry about the low light that we have over here. So I have the receiver right next to me. I turn off the LED light just because it's creating a horrible noise into the receiver. But right now, let me move the variable capacitor a little bit. And I think you can hear the oscillator into the receiver. Unfortunately, the receiver can only receive from 540 kilohertz and up. So I have it set up right now somewhere around 800 and something kilohertz, just to pick up the harmonic generated by the oscillator. Now listen to what happens when I unplug the oscillator. The receiver becomes very noisy. I'm going to plug it back in. It's a little bit harder with one hand. Let me move the light really quick. And now I'm going to play around with the variable capacitor again, so you will be able to listen to the oscillator. Now we'll go on the other side. Alright, so it works. Let me turn off the receiver really quick and I'll be right back. Alright, that's it for today. Very simple project, easy to build, the simple BFO with a simple schematic with a little bit of frequency adjustment just in case you might need it. And yeah, I hope this one will help you receive SSB and CW signals if you have a receiver with an high frequency of 455 kHz. I really wish I had a receiver somewhere around that had a high frequency of 455 kHz, because I was really curious to test this one. But I will order a PCB board for myself as well. I'm going to build it and keep it around. And I'll try to find a a receiver with a high frequency of 455 kHz just to be able to test it. But if you build one and you're using it and it works, let me know. I will be happy to hear from you. Again, I will cut the LED from the schematic just because we're going to use it with a 9 volts battery, and I want to make sure that we are reducing the power consumption as much as possible, so you will be able to use this battery for hours. So yeah, very simple project today. I hope you liked it. So thanks so much for watching. I'll see you in the next video. Until then, have an amazing rest of the week, and 73 from Yankee Oscar 6 Delta X-Ray Echo.